Welcome to this lesson. In our previous lesson, we looked at some derived quantities and the instruments used to measure them. In this lesson, we are going to look at the SI conventions and decimal multiples. At the end of the lesson, you should be able to identify specific conventions used for recording in SI units or in the SI system, and also identify the prefix and symbols for decimal multiples and submultiples. Now, there are some rules or conventions when recording SI units. First, the units should be written in full. We saw for the 7 fundamental quantities, the unit for measuring length, mentioned as the meter. So, write the meter in full. If it comes to the unit for measuring, say, time, so we have that as a second. So we have second. We write it in full. So if that for mass, we have that as kilogram. We write that in full. Under no circumstance should the meter be shortened as, say, MET, or second as SES, or kilogram as kilo. Just there. All these ones are wrong. They are not the accepted form. Also, the letter S is never used to show the plural form of the units. So if we calculate the time it takes for a person to move from point A to point B and we have it as 5 seconds, we don't write it as like this when writing it in the unit form. So the unit appropriately is 5 seconds, so we write this as small s. So we don't add another s to make it a plural form as 5ss. Or if you find the weight of a person to be, say, about 60 kilogram, we don't write that as 60 kgs. This is also wrong. So the correct form is 5 seconds. When you write it in full, then we can write it as this, but in the abbreviated form, it still ends as 5s, and it ends like that. If you want to write 60 kilograms, it's 60 kg, whether 1 or 60, the unit is still kilogram, as we have it in the unit form. Now, capital letters are used in symbols only for certain units, and these are units that goes after the names of some scientists, like the Newton for force. We look at force, we measure it as a Newton, so that is capital N. Then the Joule, we have capital J, and then we can have a large number of them. All these ones take their capital letters, so we don't write Newtons as small n or Joule as small k. Even for measuring temperature, we write the capital form Kelvin to capital K. Good. Now the symbols combined as quotients are written as such. If you're writing a quotient where we divide the numerator by the denominator, like Newton on top and second below, then the final answer is n/s or ns raised to the power -1. If we're finding density of a substance, for example, where we saw that density is equal to the mass over the volume, and we've seen that the unit for measuring mass is kilogram, and that for measuring volume is meter cube, then the final unit becomes kg /m raised to the power 3 or kg m raised to the power -3. We accept any of these forms. However, do not combine both. So kg /m raised to the power -3 is wrong. We don't combine both the / and the negative exponent. Now, this chart here, the image here shows the decimal multiples and submultiples of a number of the factors and the symbols. So if after solving and you get an answer and it's raised to the power, say we have about 10 raised to the power, say -3, and then 10 raised to the power -6. Then we refer to the 10 raised to the power 3 with a subscript as milli and the symbol m. and then the 10 raised to the power minus 6 as micro. And that takes a different shape, somewhat like this. Similarly, if they are positive exponents, like 10 raised to the power positive 3 and 10 raised to the power positive 6, then they also take different exponents. 10 raised to the power positive 3 will be a kilo. That is why we don't shorten the kilogram as kilo, because we can also write that for 10 raised to the power positive 3. We have it as kilo. We have a small k. Then we have the 10 raised to the power positive 6 as mega. And that takes capital M as a unit. So largely, this is how we write the units for a number of them and the rules we have to follow in writing the names of a number of the individual units. Now the assignment. Identify the prefix and symbol of the following factors: 10 raised to the power 21 and 10 raised to the power negative 21. In this lesson, we looked at the SI conventions and decimal multiples. We looked at the different rules or conventions that are followed when writing the names, symbols, and units of fundamental and derived quantities. We've also seen the decimal multiples and the symbol and the prefix that are used when writing the final units of some of these units, as and when they require the use of the decimal multiples. In our next lesson, we are going to look at diversity of living and non-living things. See you in the next lesson.